Hi everyone, this is just going to be a quick tutorial looking over how to import our models from 3ds into our games engines, whether that's Unreal or Unity, and also to have a look at how we can merge 3D scenes together so that you can kind of put your environments together in one 3ds Max file. It's usually common practice to model each of your assets in an individual file. It just means that you've got more flexibility over how you kind of manage your assets. It also makes it easier for export as well, just because in your final scene, when you've got everything set up, you're going to have everything kind of away from the origin of the scene, which we're going to cover in a second, which might make it difficult to export out to your engine. So I'm firstly going to have a look at the process between 3ds Max and Unreal Engine. So I've got a model here, my model car. You can see that it's comprised of a range of different models. So we've got, let's see, 5, 6, 7, 8, 9, 10, 11 different models. Some of these have been merged together, so the wheels are all just one model with multiple elements. Things like the wing mirrors are also one model with separate elements as well. And just to make it easier whilst to be modeling, I've grouped these into a dummy object. So if I just hide all of these objects, we can see that if I select the car itself, I've got this sort of point object, which is just basically an empty object. It just makes your life a bit easier to kind of have everything grouped. I know some of you like to use the group function. Personally, I don't, because it makes things a bit awkward to work with, especially when you kind of add in modifiers and stuff. I always find that using a point helper is a little bit easier. So let's just unhide all of these, and let's have a look at how we go about our export process. So the export process for getting between 3ds Max and Unreal and 3ds Max and Unity is exactly the same. We're going to be using the FBX export format. So to do this, I'm just going to make sure I select all my objects. You can select them all, or if you know that you're going to be exporting all of the objects, you can leave everything unselected and just go to File and Export. So File and Export if you're not selecting anything, but if you are selecting specific objects to be selected, use the Export Selected option instead. So I'm going to be exporting everything, so I'm just going to say Export. And it's going to ask me where I want to save this. So I've already saved this out before, but I'm just going to put this onto the desktop, Car Unreal, and I'm going to save this. So when you export as an FBX, you're going to get this FBX export window. So there's a range of different elements to kind of have a look at. We're going to go through each of these one bit at a time. So we're going to start in the include section. So this is basically what sort of information and objects do you want to include in your file. So the FBX format is preferred over things like the OBJ format just because of the extensibility of the file. You can see that FBX supports geometry, it exports animation, it supports cameras, lights and audio, and it also supports embedded media as well. So let's start at the top with our geometry. So the default selection here at the minute, in fact actually I'm on my user defined, so I'm not sure if actually this is the default selection, but these are the minimal elements that you need to include. So you'll need to include your smoothing groups. Unreal in particular will not refuse the file, but it will kick up a fuss if the smoothing groups are not present. So just a reminder that smoothing groups are not how physically smooth the model is. It's about how light reflects off a surface depending on the angle between sort of contiguous polygons. So if you've set your smoothing group maximum angle to something like 90 degrees, if your edge where two polys meet is not greater than that, you're not going to see the effect. It's not going to split the smoothing groups to get apart. So you'll need to include smoothing groups. And then next we've got tangents and binormals. So what do we mean by tangents and binormals? Well, this is from Autodesk's FBX plugin guide. Tangents and binormal data is a way to encode a tangent space representation of meshes which you can use for advanced rendering. So basically it's information that's stored about each of the vertices in a mesh, which is referred to as a tangent space. So each of the models that you have in your, each of the vertices that your model has a specific tangent component to it, sort of a directional tangent. Unreal in particular is quite sort of fussy about your model having the tangent and binormal data within the file itself. So make sure that we have this ticked on as well. And then finally we've got our preserve edge orientation. Again, so looking at the sort of documentation, editable poly objects in 3ds Max have hidden edges which can be flipped turned to change their direction. Because FBX only stores edge visibility in export files, not edge orientation, turned edges are lost, and the edges of editable polys import back to 3ds Max with the edges in their unturned, unflipped state. Activating this option means that every time hidden edges are detected, editable polys always export as editable meshes. This is because of the way that 3ds Max handles your meshes. So we have editable polys and editable meshes, which are kind of the same thing, but polys basically you can have quads where the sort of hidden edge doesn't show up on the model itself. So we need to make sure that if we've got any of those edges and you have turned them, that we need to make sure that we have preserve edge orientation on. Now, the process that we've used to model our models in the way that I model my models, it's very unlikely that we would have rotated or flipped edges anyway, but it's always good to have this ticked on. The last thing that we could have a look at is the triangulation. Now, there's a lot of different sort of schools of thought on triangulation of models. Some modelers prefer to model with triangles to start with, which obviously results in maximum compatibility between your modeling package and your games engine. The only sort of caveat is that it is a lot harder to model with triangles. Quad modeling is inherently just easier in terms of the way that sort of your edge loops work, inserting swift loops, cuts and things like that. It's always easier to model with quads. That being said, you could run a manual triangulation of your model before you export, and then you can tweak that triangulation before you export. Triangulation comes up as an issue because games engines like Unreal and Unity need to have the models triangulated to display. That's basically how rendering in games engines works. So there is an option to triangulate the mesh during export, which will result in a potentially different result that you might be expecting. We can also leave triangulate off, and then we can use Unreal or Unity's sort of import triangulation operation to result in the actual triangulated mesh, which again you have very little control, well, you have no control over, and you may not get the result that you want. Now, depending on how your model's structured, it might not be that big a deal. You know, we're talking about, for quads, which direction is our quad split. So 9 times out of 10 it's not going to be a massive deal, but it's something to consider as well. Everything else we don't really need. So the sort of the basic ones that you are going to need: smoothing groups, tangents and binormals, and edge orientation, and potentially triangulation based on your approach. I'm just going to let the engine do the triangulation because I'm fairly confident it's going to result in the sort of triangulation that I want. Next, you've got animation. Now, we don't have any animation within this file. What we're talking about with animation is, especially for import into games engines, is joint-based animation. So we're not talking about having the car start over here and then just move it over here and keyframe it. That is not going to translate over into the game's engine. Animation for games relies on joint-based animation. So we don't have any joints within our scene. We haven't created a joint skeleton, so we're not going to take animation on. We don't want to export the cameras. We don't want to export the lights. We haven't got any audio. And the final one, embed media, we want to leave this ticked on. What that basically means is it's going to look at the materials that are applied to the models currently, and it's going to export the model with those materials. Now, Unreal and Unity have a couple of limitations on how the materials will transfer across. For Unreal, it will take your diffuse map and your normal map and apply those within the material inside of Unreal. More sort of specialist maps like alpha or ambient occlusion and things like that will not map across. You have to basically set them up yourself inside of Unreal, which only takes a couple of minutes. It's not really the end of the world, but the diffuse and the normal, and I believe the specular as well, will map across from your material inside of 3DS into Unreal. So we're going to leave embed media on because I do have materials on here. Let's have a look under the advanced options. So the unit scale factor we're going to leave as 1. Now, I've made a very big deal of this in class, that before you start any of your modeling, that you should set up your scale units. This was done under the customize option, and then to customize units. We use a scale factor of centimeters inside our modeling program because Unreal and Unity both use a metric system. So Unreal uses a centimeter scale, and Unity uses a meter scale. So both of those are metric, so you should basically leave the scale factor set to 1, so it's not doing any kind of conversion. In terms of the axis conversion, this is where things get a little bit sort of tricky. Unreal is not really that difficult. Unity, sometimes you can get some quirks in terms of how the model is represented in your project browser, but then how it's actually displayed in the actual scene is usually kind of auto-converted anyway. So let's have a look at our axis conversion. At the minute, inside of 3DS, we're using what we call a Z-up right-handed system. Oh, sorry, left-handed system. Now what that means is, on your left hand, if you put your thumb facing upwards, your index finger facing forwards, and your middle finger facing out to the right, you'll see that the shape of your fingers matches the shape of the axis. So in 3ds Max's cases, the Z is up, the Y is backwards and forwards, and the X is left and right. If we look at Unreal's system, you can see that Unreal actually uses a Z up right-handed system. So if we do our right hand, the same thing, thumb up, index finger forward, and middle finger to the left, you'll see that your finger shape will match the gizmo down in the bottom left. Now that's not going to pose too much of a problem. The main thing that we'll do is that we'll use Z as the up axis to maintain that between files. So we're using Z up as our axis conversion. Our file format, by default, the FBX exporter will be set to 2014 and 15. Unreal currently, I'm using 4.24, uses the FBX 2018 exporter, so I'm just going to make sure I'm using the FBX 2018 export. And the final tab to have a look at is just the information. You can see here, FBX plugin, it doesn't really matter about the information, just to give you some information. But that is pretty much us ready to go. So I'm just going to press OK to export that out. And we didn't get any errors, anything like that. So let's now have a look at importing this into Unreal. Okay, so inside of Unreal, I've just created a new level, which has just got a simple cube in the middle of space. And in my project, my content browser, I've created a folder called imports, and inside that I've got a folder called car. When you're working on larger projects, it's important to make sure that you've got good project management, keep everything in a logical sort of system. So inside the car folder, I'm just going to right click. I'm going to say import to this folder. So it's going to take me to my desktop. I'm going to select the car Unreal FBX and press open. This is going to bring the FBX import options window open. So let's start from the top and have a look and see what we will need to do here. So firstly, we're going to look at the mesh section. So we get an option to check whether we want to import this as either a skeletal mesh or a static mesh. Inside of Unreal, you have basically two types of mesh asset. Your static mesh is anything that is just a mesh. So things like props, the car for instance, level objects, anything that doesn't have a joint skeleton that has no animation should generally be imported as a static mesh. If your FBX file has a joint skeleton in and animation, you should be importing it as a skeletal mesh. Unreal handles these two types of meshes very differently. Now because we don't have any joint structure inside of our FBX, we're going to leave it as a static mesh. We're going to auto-generate collision. And you might not be able to see this on yours by default, this little white arrow here, if you just open this up. The one that we want to make sure we've got ticked on is the combine meshes. If you've got a multiple mesh object, kind of like this one here, if you don't have that ticked, it's going to import them all in, but as separate pieces, which you may want to do if you want to have a bit more flexibility over how this car kind of works. It might be that you have one blueprint of all of the parts put together, and you can maybe have, animation of bits falling off and stuff. You may want to do that, but for the purpose of my import, I want to make sure that I am combining the meshes together. Okay, the next thing to have a look at is under the miscellaneous section. So we've got, can we convert the scene? Do we want to force front x-axis, and do we want to convert the scene unit? Now, this really should only be done if you haven't set up your scale system out in your modeling program. If you set your modeling scale correctly, you won't need to convert the scene unit. Converting the scene, however, is probably going to be for the best because we can't get an exact one-to-one mapping of our coordinate system from 3DS into Unreal. It might be a good idea to convert the scene. Now, if you convert the scene, what it will do is you're not going to get an exact map, but the model will import the correct orientation. If you exported from 3DS using Y up instead of Z up, and you don't convert the scene, what will happen is your objects will be rotated by 90 degrees and will look like they're pointing upwards, which obviously you don't want. Now, this option here in the middle is an interesting one, forcing the front x-axis. Now, historically, Unreal Engine has always used the x-axis as the front axis. Unlike pretty much every other 3D program that I've ever worked with, where the x-axis is the side-to-side axis, Unreal uses the x-axis as the forward axis. So again, it's not imperative that you turn this on. What this will basically mean, and what it will do is it will try and rotate your object so that it's facing forward on the x-axis rather than the y-axis. And when you're creating your blueprints, basically all this is doing is it's eliminating the need for you to have to rotate your object inside your blueprint. What I'll do is I'll import this multiple times so that you can see the difference. So I'm going to import this firstly without the x-axis, and then we'll do it again with forcing the front axis. So once I've got that all done, I'm just going to press import. It does give me some warning, so I've got some degenerate tangent bases. That might be something to have a look on. Again, it's not really, it's not a massive warning, a massive error, it's just a warning. It may, it will result in incorrect shading. We'll have a look at the model and see if there's anything we can tweak. and then there's some nearly zero binormals which can create some issues. Now this might be to do with sort of the spacing between some of the vertices of my model. I've got some areas of the model that are quite dense, but again, it's not going to break anything. It's just a warning to say that it might not look the way that I want. So I'm just going to close the message log. I've now got my static mesh. You can see that it has a blue line underneath to highlight that this is a static mesh. It's brought in our texture map, which has the red line underneath, and we've got our material, which has the green line underneath. So if we open up the material editor, you can see that it has already auto-populated my diffuse map into the base color channel. So I don't really need to do anything else. My material didn't have any other kinds of maps. It didn't have a specular or a normal or anything like that, but I can always come in and add them myself. So if I click and drag my car into my level, you'll see that I will get the object in. And if we have a look around how the axis system works, you can see that it is using the Z up and the Y forward, and the x-axis out to the left, which is not the same as our system within 3ds. You can see that our Y is actually facing backwards, but the main thing is that we've got the model in and it's at the sort of correct orientation without having to do any kind of major modifications. One thing that is going to be a slight annoyance is if we try and use this inside of a blueprint. So if I just create a new blueprint class of type actor, let's just call it car. And let's just go to my components and add a static mesh. If I now go to a side view, so if I look at this from, let's say, the left view, and I import my car, you'll see that even though I'm in the side view, it looks like I'm looking at the car from the front, or the back even. So you might be thinking, well, what's going on? Why, if I'm looking at the front view, am I seeing the side view? And this is because, as I mentioned before, Unreal Engine uses the x-axis as the forward axis. So in every blueprint, if you've got any code which is dependent on using the forward vector of your blueprint, which is going to be this direction, you'd need to make sure any visual representation matches that expectation by rotating all of your static meshes by 90 degrees on the z-axis. Now, that is a minor inconvenience, but if you have a lot of instances of this kind of thing and you want to make sure that you're getting everything right the first time, you can simply just import the mesh with the x-axis forward. So if I just go back into my imports folder, I'm just going to import this into here again. I'm just going to say yes to all. See if we can re-import. Nope. Oh, just delete it out first. Okay, that'll just remove it from the car. There we go. Okay, so if I go back to import again and just import the car again, this time I'm actually going to try with my normal generation to use the built-in normals as well. Import normals and tangents, and let's just go and say force the front x-axis. There we go. So, didn't get any warnings on import this time. Let's just have a look at the static mesh editor. You can see that it's now pointing forward on the x-axis. So if I go back into my car blueprint, let's just go to the viewport and my static mesh. I'm just going to select the car again, and you'll see now that the car has imported and is using the correct axis for Unreal. So that's probably going to be the best way to work with your static meshes when importing them into Unreal, to use the force x-axis to get them to look in the correct orientation. Okay, one thing to have a look at as well with Unreal, just before we move on to looking at Unity, is the pivot point of your object. So if we go to back to 3ds, let's have a look at how I've actually got the scene set up here. So my car is all set into a sort of null object, which is centered to my scene. If I move the car's pivot point, let's say over here like this, and then export this out, it's going to cause us a lot of issues inside of Unreal. So I'm going to go to File, Export, and save it over the top of this one again. Just use all of the same settings and press OK. If I go back to Unreal, and just select my car Unreal and just say re-import, you can now see if I put my car inside of the level that we've got some issues with our pivot point in that the car is offset. Now this is because the exporter for, the importer for Unreal treats the center of your scene as the pivot point. So even if you've got the car or any object grouped under a null object like this, it will disregard where that's positioned and it will use this as the center of your scene. This is going to make it really awkward for positioning objects inside of Unreal. So if I click and drag out another static mesh, you can see that if I want to rotate it, it will kind of rotate with the offset. So very important inside of 3ds that before you export anything, that you just reset the pivot points to make sure that your object is centered. Now, if you don't have your objects in a group like this, if you've got them sort of as the, as individual objects, again, all you need to do is just make sure that it's roughly centered. I would make sure that when you're modeling that you're kind of using your grid and making sure that you're always modeling it in the center anyway, so you don't have that issue. But in the past, one of the issues I've seen from students before is they'll always be asking kind of, why can I not rotate my object properly? It'll be to do with how the pivot point has been set up inside of 3ds. So I'm just going to re-export this back out, just say yeah, there we go. Let's go back into Unreal and let's re-import this. And you see that as soon as we did that, it snapped right back to where it needed to go, which is absolutely spot on. I still got this rotated by 90 degrees. Yes, I do. That's why it's not appearing correct. So there we go. So compile that one. There we go. So it's got the correct thumbnail. So you can see now if I just import or drag in another instance of this model, now if I want to rotate it, it rotates as you would expect. So that's basically the export import process for 3ds to Unreal. Next we'll have a look at how the export process will work for Unity.